Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for watching IT Pro TV, helping you level up with IT learning everywhere you go. I'm your host, Zach Memmis, for this episode of CompTIA Linux Plus. We're going to be filtering traffic with firewalld. You want to do that too? Sure you do. And Don Bizzetta is here to show us the way. Don, thank you for joining us.
Hey, glad to be here. We are going to be looking at firewalld, which is probably the most common host-based firewall that's installed on Linux systems. If you're running Ubuntu, CentOS, really Red Hat Enterprise Linux, they've all moved over to firewalld from IP tables, which used to be the most popular. So in this episode, we're going to learn a little bit about firewalld, how it works, how we configure it, how we verify that it's even operational, and how we can kind of manipulate rules to make sure that our system is safe and secure. So that's all coming up right here in this episode.
But Don, why would I use firewalld over IP tables?
All right, so IP tables was the de facto standard for a long time. Most distros, like with CentOS or Red Hat Enterprise Linux, in version 6, they were running IP tables as the default firewall. When they went to 7, they switched to firewalld. And the main driver behind that was systemd. Firewalld is designed to integrate a little better with systemd than IP tables was. Now, you actually have the choice. You can have systemd and run IP tables on top, or you can have firewalld running on top. It's your choice. And just because your distro ships with one doesn't mean you can't switch to the other. In fact, we'll cover IP tables in another episode, and I'll show how to switch from systemd over to IP tables if you love it and you want to go that way. But the main challenge with IP tables was its configuration. It was just a difficult thing to configure. The way the configuration files were written were complex. It was very easy to make a mistake, and then it would cascade and break everything. With firewalld, it works on this rule-based system where we have a specific command to do the modification. We're not directly editing the config files anymore. And that means if we mess up one rule, it's not going to cascade and affect the other rules unless we are maybe granting out too much permission, something like that. So firewalld gives us a little bit better access and some better management tools. So that's the main reason why people have made that switch over from one to the other. But I'm not saying don't run IP tables. If your environment is dedicated to that and your staff is already trained on it, there's value in that too, and it's still fully supported. So it's kind of a neat time right now where you've got that choice. But for me, on new systems, I always do firewalld. It's just easier to manage. That's the main reason.
So how do we know if we're running firewalld?
There's a few different ways to do it. One of the easiest ways is just to look and see if the firewalld service is running on your system. IP tables and firewalld both run as services. And it's worth noting that they're both really just configuration interfaces, because on the back end, they're both just calling the NetFilter service that kind of runs. So they're really using the same filtering protocol. So performance-wise, they should perform at the same rate. But on my system, what I can do is open up a terminal. And usually, if I want to know, if I just want to figure out real quick, I'll do something like, we could look at the service. So I could do a systemctl status firewalld. If you get nothing back, you're not running firewalld. Easy, right? But if you get a response back like this that says it's active and running, that's a pretty good indicator that you're running firewalld. If I did the same thing for IP tables and put a proper space in there, I get service cannot be found. Right? Now, I could have firewalld installed, but not running as a service. Maybe I haven't activated it, so that's always a possibility. You could look and see if the packages were installed. But on most systems, it's installed by default these days, so you usually have it. We could also use firewalld's interface. In order to interact with firewalld, we're going to use the firewall-cmd. This is the firewall command line. And with firewall-cmd, you can ask it all sorts of things, like ask it to tell you its status by doing a -- state. Now, you do need to be an administrator to do that, so I'm going to sudo that command. And when I run it, I can see that it is running. So I didn't have to use systemctl to pull it up. I could have pulled it right here from firewall-cmd. Now, I'm going to be using that firewall-cmd command a lot the rest of the show, and I've always got to sudo it. So to save a little bit of time, I'm going to do a sudo -s and switch to a root context. Whoops, or not. Oh, yeah, there we go. I switched. So sudo -s. This means every command I run the rest of the show is being run with elevated privileges. If you do this in real life, you've got to make sure you exit out of this when you're done. Otherwise, you've got a root session open. And if you start running mundane tasks, they're actually running with elevated privileges. So you want to be careful with that. But for configuring the firewall, it's kind of a handy thing to do to save you from sudoing over and over.
So how do we get started to configure the firewall, Don?
Well, if we want to work with it, one of the first things we need to understand is how it works,
Hmm.
right? The way firewalld works is it takes your network interfaces and it puts them in zones. And the zones are how we filter. When traffic goes from one zone to another, it gets filtered. If I have two interfaces in the same zone, they don't get filtered. It's just passing between the interfaces, right? We don't usually have that. Normally, you have like an inside and an outside, or an internet and a LAN, or something of that nature, and those are your zones. If you do firewall cmd get zones, you'll see the list of zones you have. And most distros create a handful of them by default. I've got a lot here: block, DMZ, drop, external, home, internal, public, trusted, work. And they all have different policies attached to them, right? So, like the trusted rule, that zone probably allows a lot of traffic in and out. But if we take something like block, that doesn't allow any traffic in and out. Or DMZ is probably pretty restricted. It probably allows a lot of traffic out, but not in. So each of these have different rules kind of defined for them. Now, just because I see a bunch of zones here, what do I have? 8, 9 different zones, doesn't mean they're actually running. You usually just have like one zone attached to all of your interfaces by default. There's a default zone. Now, looking at this output, I don't know who the default is, but if I change that command a little bit, and I'm going to say firewall-cmd get default zone, that's going to tell me which one is the default. My default is public. And so all of my network adapters right now are going to be tied to that public zone unless I've changed it, right? So, it just sticks them in this default zone. And whatever policy is attached to that is the one that is going to be applying. If I ever want to see like which zones are actually active, I can do firewall-cmd get active zones. And remember, I had a list of like 9 different zones a minute ago. Now I get a list of just one. It's only going to show me zones that actually have an interface attached to them. And I see my network interface right there. ENS33 is tied to that public zone. If I had 3 interfaces, I would see exactly which zone each one was attached to. So that's important. We can't jump in and modify rules until we know where to modify the rules at. We have to know which zone the traffic is coming in or which zone the traffic is going out. Now, most of the rules that we write are incoming rules. We catch traffic as it comes in an interface, but you can do outbound rules as well. So, it's just kind of understanding that flow of traffic right through here. You can create your own zones if you want. Usually just reusing the ones that are here are pretty adequate. But if you want to go a step further, you've got firewall-cmd followed by --new zone equals, and then you can create a zone. So I might want to create one called test lab, like that. Now, if I just run that command, it's going to run and I get an error, right? With firewall CMD, there's actually 2 configurations. There's the configuration that's running in RAM, and there's the configuration that's written to disk. Normally, when you run firewall CMD commands, it's running against RAM. Zones are one of the exceptions. Zones have to be written to disk. And so it's telling me to use --permanent, which says don't write it to RAM, write it to disk instead. And so I'm going to add that. I'm mentioning that now because later, when we add rules, if you don't do --permanent, then the rules are just being written to RAM. And when you reboot, you lose them. So we have to remember to throw that little --permanent in there as we do it. Now, if you do --permanent, it doesn't apply to RAM. So then we would need to restart the firewall to load these rules, which is kind of annoying. So we usually end up having to run commands twice, once to apply to RAM and once to apply to disk. But once we've got that, I've got my new zone created, and I can do a firewall-cmd -list-all, and that's going to return, oh, sorry, that's my active ones. I need to do get-zones. And, oh, I just got done explaining to you guys that this wrote to disk and not to RAM, and I need to restart my firewall service, and then I didn't restart it. So I don't see that new zone that I just added. So I'm going to do a firewall-cmd --reload. I need to listen to the words that are coming out of my mouth sometimes. There we go. So I reload that firewall, and now when I go and get the zones, I should see my test lab. There it is right there. It's loaded, and it's present. So that's how we kind of add a zone, and we start working with firewall D.
Well, how do we assign a network interface to a zone, though?
All right, so the interfaces are attached to zones when they come online. All right, so when an interface comes online, it has a network script that gets pulled. So my ENS33, for example, if let's see if we can find it here, it's going to be /etc/sysconfig and then, whoops, sysconfig / network scripts / ifcfg followed by the name of the interface. So mine is ENS33. So if I take a look at that file, right here are all the settings that apply to that interface when it boots up. Okay. And if I look at that very last line right there, see how it says zone equals public? That's where it's getting that zone from. So it got the default zone applied to it. If I want that to be in the test lab zone, I would just edit that file and change public to test lab. And now when the interface comes online, it'll be in the proper zone. So that's how we rearrange those. Ubuntu maintains scripts just like these. They're just in a different folder. But it all kind of boils down to what script is configuring that network adapter. That's going to assign the zone. On Ubuntu, they actually have a GUI for firewalld that you can use as well. It's a little bit easier. But from the command line, it's done right here in the script files. Once you set an interface like that, it doesn't actually take effect until it reconnects. So you could take the interface down and bring it back online again. That's one way to do it. Or you could just restart the network service. I've only got one network adapter, so it's actually faster to restart the network service. But if I'm on a server, I probably don't want to do that, right? That would have a pretty big impact. But I can just come in and say systemctl restart network, and that would restart the whole network service and reset the interfaces. Or I could do, systemctl restart firewalld so that it sees the change and applies it into the zone as well. So a couple of different options there. And you can verify that it's done by doing that firewall-cmd -- get-active -zones. And you should see your interface showing up in that new zone once that's been modified. So not too hard, really just editing that script.
Well, how do we use the zone to manage traffic, sir?
All right, so this is what we're really going to do. If you're like me, I don't really care what the zones are called. So this zone is called public. Fine, what do I care, right? So I'll just stick with public. And I can then customize the rules that are on that zone to meet my needs. Now, there might already be a couple of rules in place, so I'll need to evaluate those, but I can jump in and start to create my own and get them put in. Now, to create a rule, what you're going to do is either allow or block a service to pass through your firewall, right? So in order to do that, we need to know what services are supported. And firewalld comes with a whole list of pre-configured services you can reach into and use. If you run firewall-cmd -get-services, when you run that, it will show you all of the supported services right there. And more importantly, it's telling you the firewalld approved name for that service. Because, browsing the web, is it called HTTP or is it called www or is it called web? Right? If you've worked on Cisco equipment, they do all three. It's super annoying. But here in firewalld, they don't. So I can look in and I can find, it's just called HTTP. That's what it's called. If I want to allow that through the firewall, that's the service that I'm going to approve. And if you ever want to see where these are defined, they are tucked away. If I do I'll do a listing here for /usr/lib/firewalld/services. And in that folder, you'll find a bunch of XML files. These are defining the services. So I saw HTTP in my list, and so somewhere in here, right here, is http.xml. And if I were to pull that one up, let me just cat that to my screen here. There we go. What you'll see is a little XML document that defines what it is. And it's just saying, hey, this is HTTP traffic. And it gives you a little description to tell you that's what that protocol happens to be. But most importantly is this line right here. It says, oh yeah, that uses TCP port 80. Some protocols are more complex, right? Like FTP. If I look back in my list here, FTP is defined, right? Let's look at its file. So if I cat that one and look at it, it has more. It has TCP port 21, but then it's calling the NetFilter connection tracker. Remember I said this is all using NetFilter? To fire that up because passive mode SFTP will jump to all sorts of crazy ports. It'll jump to 30,005, 42,178. You don't know what it's going to be. So it's got to track that. And so it's got a module that's designed to be able to track that and identify those ports and open them as needed. So those XML files are pretty important. And that's where these services come from. But once I know the service I want to allow, let's say I want to allow HTTP and FTP, then what I would do is I would come in and say firewall-cmd --zone equals and specify the zone. Now, my network interface is tied to the public zone. And the public zone right now is my default. We saw that earlier. So since it's the default, I can actually just leave the zone off. If I wanted to specifically apply to a zone, I could say like zone equals test lab, right? That would be one zone in particular. But if I'm modifying the default zone, I can just leave that off. On a workstation, you usually only have one network adapter, so you just have one zone. You make it the default, and that's that. So I'll leave that part off, and then I'm going to say dash dash permanent because I want to write this to disk, and I'll do dash dash add dash service equals HTTP, right? And then I will do the same thing for FTP. So I'm allowing those two services. Now, that applied to disk, okay? If I run it without dash dash permanent, right? So if I just come in and run it that way, that's a success also. The difference here is I'm modifying what's running in RAM, and I didn't have to reload the firewall to do it, right? That's something that we really couldn't do under IP tables, but we can under firewalld. I had to do two sets of commands, but I didn't have to restart the service. That means any network traffic that I have going on right now didn't get interrupted, which is a good thing, and I've allowed it. So dash dash permanent writes to disk, leave that off, and you're writing to RAM. Those settings are now in place. And if I want to see what happened, I can do firewall dash CMD, and then specify a zone if I need to, or if I'm doing the default zone, I can leave that off. And then I'll just do dash dash list dash services, and that's going to show me what's configured. Now remember, I'm reusing the public zone right now. I don't know what was allowed through it. So list dash services will tell me. And I know I'm going to see FTP and HTTP right there, but I can also see that SSH is allowed, and the DHCP v6 client for getting a IPv6 address is being allowed also. I'm okay with both of those, so I'm going to leave them be. If not, I could go in and do a remove service instead of an add service to take those away and get them blocked on the firewall. But I can see that here. This is showing me what's in RAM. If I do a dash dash permanent, though, I can see what's written to disk. And you may find where what's written to disk is different than what's in RAM. This is a great way to check that. But dash dash list dash services shows me what's going to be allowed to come through that firewall.
What if we want to manage non-standard traffic, Don?
All right, so let's say that I'm going to bring up a web server, and I'm going to bring it up on port 8080. You know, maybe it's just some kind of internal thing that I'm going to use. It's not something that I'm going to put out on the internet. Or heck, maybe I am. I don't know. Maybe I get some crazy custom protocol. Well, you got a few options, right? So option one, you could go and define one of those XML files. You could create a service XML file that defined your service, and you could give it a nice little name. And then you do what I just did right here, and you would add that to your firewall and be in business, okay? Or if you want to forgo writing the XML files because it can be kind of annoying, you can just approve the port numbers. So I've been using service names, but you can just go with the straight up port numbers and put those in if you know how your protocol behaves and what it needs. I just need port 8080, not a big deal. So for that, you know, the first thing I want to do is do a firewall CMD dash dash get dash services just to see if the protocol is already defined, right? Well, in my case, I'm doing something non-standard, so I know it's not defined. I've got to go ahead and define it myself. And so we can do that by saying firewall dash CMD, specifying a zone if need be. Mine's the default, so I'll leave that off. I'll do dash dash permanent. And then dash dash, instead of add dash service, I'm going to do add dash port. So I'm adding a specific port in place. And from here, I can say equals 8080/TCP. Okay, so 8080 is the port number. And then I'm doing / to identify that it's just TCP. If I leave that off, it's going to be port 80 for TCP and UDP. So I have to decide whether or not that's what I want. Typically, it isn't. So I'm just allowing that TCP traffic. And when I add that, it's going to add that non-standard port to the list. And you can even go and do like a range. I see this with voice over IP, where they say, yeah, you're going to be getting traffic, and it's going to be on UDP port 50,000 to 60,000. It's a huge range, right? So what you could do for that is same basic command, except when you do add dash port, what you're going to do is come through and say, like this, we'll do 50,000 hyphen 60,000 / UDP. And so that's going to hit that whole range and get them approved. So that's going to get tucked on there. All right. Now, if we want to verify if this is all working, we can do firewall dash CMD dash dash permanent, because I haven't brought it into RAM yet, right? This is just on my disk. And then what we did before was get dash services, right? to give me that list. Oh, sorry, not get dash services. It was list dash services. Helps if you run the right command. So let me do list dash services. There. And so I saw the names of what was approved. Notice this didn't change. I don't have port 8080. I don't have 50,000 through 60,000 because they're not services. They're ports. So I need to run list dash ports in order to see that. And when I run that, I'll just see the raw port numbers that I approved through the firewall. And so there they are, 8080/TCP and 50,000 through 60,000/UDP. Those are now being allowed to come into my system and reach in. So I've opened that traffic up, and now it's allowed to come through. So that's all kind of a part of how we manage firewalld.
Exciting stuff. Filtering traffic with firewalld. Wonderful episode. Once again, Don. Good stuff. And anything else you'd like to say?
You know, really, we just touched on the tip of the iceberg here. You know, what we need to know for basic Linux administration. If you get more advanced with this stuff, you'll learn that there's a lot more you can do with the rules, right? In all the rules that I wrote in this episode, it was always saying anybody on the outside can come in on port 80, or anybody on the outside can come in on this IP. But usually we'll want to specify something a little bit more granular. We want to say this one public IP is allowed to come in on UDP, whatever. You can do that with firewalld. It has support for more complex rules, but on a simple basis, it's really easy to just open and close ports. And on a end user workstation, like on a desktop, that's typically more than enough. So pretty easy to work with here, but know that it can get a lot more complex to meet your needs.
Great advice as usual. Thank you, Don. And more great advice. Watch every episode of CompTIA Linux Plus. You're going to be so glad you did. It's going to help you now and in the future. And you know the exam. Yes, it's inevitable. It's going to be coming. So make sure you keep studying, keep learning. And inside our course library, there's thousands and thousands of videos you can take advantage of. Supplementary information that will help you go further. So check that out too. And tell everybody you know about IT Pro TV. IT Pro TV is binge-worthy. Thanks for watching. I'm Zach Memis.
And I'm Don Pizzette.
We will see you again soon.
Thank you for watching IT Pro TV.